Alright everybody, welcome to the video here for lesson number 7, the Pythagorean Identity. So in class today we learned that there were a couple different Pythagorean identities that we can use, and we're going to try and use all of them in the homework assignment here tonight. Some of these questions could be asked without the Pythagorean identities, but there are times on the Regents exam where they specifically ask you to use them, and sometimes they're actually the easier method to use. So let's take a look at this first one. So it says use a Pythagorean identity to find sine squared plus cosine squared equals 1 for theta is any real number, and it asks us to find the meaning of tangent given the cosine. So if we know the cosine, using the Pythagorean identity, we should be able to find the sine, and then we could just divide the two to find the tangent. Okay. So there's a couple pieces of information that they give us here for sure. It tells us what quadrant we're in. This whole thing here tells us that we're in quadrant 3. Quadrant 3 meaning sine and cosine should both be negative, and the tangent value that we're getting for our answer should wind up being positive. So let's plug in what we know. So we don't know sine. We know cosine. So I could just plug it in for where cosine squared is. So I still don't know sine squared. If I square 1 over radical 2, I just get 1/2. Subtract 1/2 to the other side. And we get sine squared of theta is equal to 1/2. Meaning the sine of theta is equal to the square root of 1/2, which is 1 over the square root of 2. But since we're in quadrant 2, I'm going to use the negative version here. So now I know a couple things. I know the sine of this angle, and I know the cosine of this angle. So let's just show what I know. So I know the cosine of this angle is negative 1 over radical 2. I know the sine of this angle is equal to negative 1 over radical 2. Meaning I should know the tangent of this angle, which is equal to the sine over the cosine, which is negative 1 over radical 2 over negative 1 over radical 2. Now, anytime I divide something by itself, I get 1. So if I divide a negative by negative, I get a positive 1. So this answer should just be positive 1. Again, this is not the only way of finding this angle. I could have made a quadrant 3 triangle, used the adjacent hypotenuse side, used the Pythagorean theorem to find the missing side, do tangent, and do all of that. It's going to be the same answer. This is just an alternate method. Okay. So let's look at number 2. Number 2 gives us a quadrant 1 angle. It tells us the sine value, and it wants us to find the cosine value. In retrospect, this should have been the first question in the homework, because this is way easier than the first one. So, again, it doesn't tell us to use a Pythagorean identity, but we're going to use it because that's the topic that we covered today. So I know that sine squared plus cosine squared equals 1. If I do some quick math here, 1 over radical 3 squared, well, that's just 1 over 3. Move this to the other side. So now I know that cosine squared of theta equals 2 over 3. I like fractions here. I don't like decimals. Some questions might even ask you to just round it to nearest tenth or something like that, and that's fine, right? But I do want to make sure that we are using fractions whenever we can. Now keep in mind, when you take the square root here, you're going to get two answers, both positive and negative. So I have cosine of theta equals plus or minus radical 2/3. But because we're in quadrant 1, I just want the positive answer. So I'm going to get radical 2 over 3. That's an okay answer. If you're an accelerated, I would expect you to do this extra step, which would be rationalizing so that we get a nicer looking answer. But either way, it's the same value. Number 3 gives us a quadrant 3 angle. It tells us tangent, and it wants us to find the value of secant. Now, we could go through and draw a triangle and do all of that, and that works, but let's use our Pythagorean identities here. So in class, we derived a couple different ones. So let's just take a look at one here. So if I have cosine squared of theta, actually, let's do it the same way we did in class. I started with sine, right? So we could say sine squared of theta plus cosine squared of theta equals 1. Now, I'm given tangent and I want to find secant, so I want to change or manipulate this equation so that it has tangent or secant in it. Well, to get tangent, we know tangent is sine over cosine. So if I divide everything here by cosine squared, I'm going to get sine over cosine, which is tangent. I'm going to get 1. And that's going to be equal to secant squared of theta. So I've chosen to use the Pythagorean identity and manipulate it so that it gives me tangent and secant. It just makes this so much easier. Because now I know tangent is 2.5, so I can put in 2.5 squared plus 1 is equal to the secant squared of theta. Notice I don't even have to make a triangle here, and I have some information already. So I know 2.5 squared plus 1 equals 7.25. Square root both sides, and I'm going to get that the secant of theta could be either positive or negative the square root of 7.25, which is to the nearest tenth, 2.7. Now, keep in mind, we're in quadrant 3. So because we're in quadrant 3, I know cosine is negative, therefore secant is negative. So yes, I got two answers here, but we just want the negative one because of what quadrant we're in. That's why in lesson 6 I was going on and on and on in class, I'm sure, about the positive and negatives and knowing where everything is positive and negative. So that's a really good example of where the Pythagorean identity would be easier. If we were to use this not as the Pythagorean identity and make triangles, we'd have to make a right triangle in quadrant 3. We'd have to then figure out what 2.5 was as a fraction, figure out what the opposite and adjacent side were. We'd have to use the Pythagorean theorem to find the missing side. Then we'd have to go through and find the cosine, take the reciprocal of it, and then show it as a decimal. That would be a total pain in the butt, and honestly, this is way easier, right? So one of the things that we did in class was we talked about this Pythagorean identity. We didn't do much in the way of proving it. So I want to prove it here for you. I'm hoping that you're able to kind of keep up with me here. If you're having trouble, after I give you the first step here, maybe pause it and then try and go from there. So this needs to work for any triangle. So if I just draw a generic right triangle with theta in it, and I make one side A, one side B, and one side C for the Pythagorean theorem, I should be able to identify where this comes from. So if I found the sine of this angle, sine is opposite, so B, over hypotenuse, C. If I was to find the cosine of this angle, that would be the adjacent A over hypotenuse C. This is the first big step, is identifying what ratios that we have here. So from this point forward, see if you can prove this identity. All right, so I'm hoping that you were able to try that real quick. If you didn't get a chance to, or you were unsure of what to do next, you could just follow along with me here. So to prove the Pythagorean identity, we have to be able to prove that I can come up with this using just Pythagorean theorem. So Pythagorean theorem says a squared plus b squared equals c squared. Well, since I want to make it so that it's sine squared plus cosine squared equals 1, well, I have to figure out what I can do to this c squared to make it 1. Well, I could just divide it by itself, because anytime you divide something by itself, it just becomes 1. So then let's clean this up a little bit. If I have something squared divided by something squared, I could just say it's that fraction squared, and that fraction squared is equal to 1. And then, hey, look, those fractions are familiar to us. Cosine is the same as any adjacent side over any hypotenuse. So this represents any adjacent side over any hypotenuse. So we could say this is just cosine squared. The second part is b over c, which we said was sine. So I could say this is sine squared equals 1. This is the same exact thing as what's above. Obviously, the commutative property of addition allows us to switch the sine and cosine to make it look exactly the same, but that is the same thing. So that's how we're deriving this. This works for any values of a, b, and c that make a right triangle, thus proving the Pythagorean identity. All right, so let's take a look at the last one. The last one says that segment BD is cotangent, so I'll label that in my picture. It says that BO is cosecant, so I'll label that in my picture. And it says that prove that 1 plus cotangent squared equals cosecant squared. So looking at this, if this is the unit circle, if I just look at this one triangle, the other piece of information I need to be able to prove this is that OD is equal to 1 because it's the radius of the unit circle. Because this is a right triangle, I can do 1 squared plus cotangent squared equals cosecant squared. I know that because of the Pythagorean theorem. Notice I'm ignoring pretty much everything else in this picture. I know 1 squared is just 1. So I'm done. So by them just giving this piece of information of this being the unit circle, I knew one of the sides of the triangle. They told us the other two, so I could essentially just plug it in. The other way of proving this would be to prove that this is a similar triangle to the generic one that we know, sine squared plus cosine squared equals 1. And then since they are similar to each other, their side turn ratio, all that good stuff, but you don't need to know any of that. You just need to be able to go through and find the deriving of this from the picture. The other way I could ask you to derive this would be to start from the original triangle of sine squared cosine squared equals 1. Divide everything by sine squared, and you get those three expressions like we did in, I think it was number 2 in the homework, or number 3 in the homework to derive the other one. So essentially from this lesson, you should know 3 things. You should know that sine squared of any angle plus cosine squared of any angle is equal to 1. You should know that if you divide all these by sine squared, you get 1 plus cotangent squared is equal to cosecant squared. If you were to divide all these by cosine, you'd wind up getting tangent squared plus 1 is equal to secant squared. So there's essentially 3 different identities that are all derived from that original one. Okay? Hopefully this video is helping and you're watching them. I know a couple of you definitely are, and I know some of you definitely aren't, so tell your friends to watch them because they're riveting. In Cognole, I won't say the thing here today. I don't think I did anything that would make you laugh here, but I might have. I'm not really sure at this point anymore. All right, so good luck, and I will see you all tomorrow.